Welcome to our Software Design and Development unit. In today's lesson, we will look at the implementation of data types and structures, and we will also look at the implementation of some computational constructs, such as expressions to assign values and expressions to return values using arithmetic operators. Our learning intentions for today are learn how data is stored in a program using variables and arrays, learn how variables and arrays are implemented using 6 different types of data, and learn how calculations are performed and the purpose of arithmetic operators. As always, we have success criteria for our lesson. Today, our success criteria is being able to describe the 6 data types and identify when it is appropriate to use them, be able to create variables and arrays using each of the 6 data types, be able to assign and retrieve values from variables and arrays, be able to name variables and arrays in accordance with the lower camel case naming convention, and be able to describe the 6 arithmetic operators and identify when it is appropriate to use them. As always, our learning intentions and success criteria should be referred to throughout the lesson, and this will let you know how successful you are being during the learning. When developing a software solution, programmers will use variables to store data in their programs. A variable can be thought of as a box where you can store data. The box should be given a name to describe what it contains. This is referred to as a meaningful variable name. It helps with the readability of the code. We'll learn about readability later. Variables can store one piece of data at a time, but it should be noted that the data contained within the variable can change. This is why it's called a variable. When we declare a variable, it creates a named storage location in the computer's memory. Well, how do we set up a variable? Variables are declared at the start of the program. They're created using a command word or a declaration command, dim. Dim stands for dimension. The variable is then given an appropriate name. In this case, we are storing someone's age, therefore we call the variable age. We also must tell the computer which type of data will be stored inside this variable. In this case, we have declared the variable age as an integer. It is a whole number. Different variables may be declared or used to store different types of data and various pieces of information that we require throughout the program. As mentioned earlier, each variable can hold a single type of data and piece of information. This is declared by the programmer at the time when they set up the variable. Some common variable types and data types can be seen in the table. A char is a single character. A string is multiple characters. An integer is a whole number. Single is declared as a real number, so it's a fractional component to it. A double is a real number with a fractional component. The difference between a single and a double is a double gives a greater amount of decimal places. Therefore, we can store numbers that are extremely accurate. The downside of this is that it takes up more memory. Finally, we have a boolean, which is true or false. All of these data types will be used at some point during the programs that we create. Earlier we mentioned that we can store data in our variables. Well, how do we do this? We do this using a method called assignment. Variables can be assigned values in a number of different ways. They can be assigned via direct assignment, as we can see here, from a calculation, as results would be assigned to a variable, or from the contents of other variables. We may want to take the contents from one variable to another. Variables always have to be assigned a value that matches their data type. For example, a variable declared as an integer, as we see here, must always be assigned a whole number. Again, in our example, we have a variable declared as dimAge as integer. The name of the variable is age, and it will store whole numbers. In this case, we see our variable circled. It's called age, and it is assigned using our assignment operator, the value of 16. This is how we assign data to our variables. The second way of assigning data to a variable is via a calculation. We can assign the result of a calculation to our variable. In this example, we have our variable area declared as a single, which is a real number. We have our variable area circled, our assignment operator once again, and our calculation. Notice we have a multiplication operator, which is the asterisk in this case. In our last slide, we used the multiplication operator. There are a number of arithmetic operators which we can use to perform calculations. The multiplication operator that we can see in our example is just one. Here are some others. We have addition, subtraction, multiplication, division, exponential, which raises the value of a variable to the power of another, and modulo, which will identify the remainder of a division. We will use these arithmetic operators in calculations throughout our programs. The third method of assigning data into our variable is via a calculation that uses the values stored within other variables. In this example, we have a calculation that contains two variables. The values of those variables, width of rectangle and height of rectangle, will be multiplied together and stored in our variable area. In this example, the width of rectangle, the value contained within it is 10, and the value contained within the height of rectangle is 5. Our example here would give a result of 50. That value would then be assigned to our variable area. Therefore, our variable area would contain the value 50. Up until now, we have spoken about assigning single values to our variables. One piece of data can be stored in a variable. It's often necessary to store multiple values of the same data type. The most efficient way of doing this is using an array. Arrays are declared in a very similar fashion to a variable. We use a declaration command, which is dim, standing for dimension. We give our array a meaningful name so that we know which site is stored inside it. In this case, it is grades. We then need to tell the computer how big our array should be, or how many pieces of data we plan to store. Inside our parenthesis, we give a number. This tells the computer how many elements we want within our array. We can store a piece of data within each element. These elements are identified using indexes. From the table below, you can see our array grades has 6 indexes. The reason for this is that our array elements always start at index 0. 0, 1, 2, 3, 4, 5 gives us 6 elements in total. Also in the table, you can see the items of data that are stored within each element. In index 0, the data item A is stored. In index 3, the data item B is stored, and so on. As always, we need to give a data type for our array. In this case, it's set as char, which is a single character. In our previous slide, we spoke about arrays and setting up arrays. We also described briefly about each item in the array being given a unique position. That is indicated by an index number. In this case, grades index 0 contains the data A. Grades index 5 contains the data D. We can access our data using these indexes. The array of grades to the left contains 6 grades. The first grade has an index of 0 and the last grade an index of 5, giving us a total of 6 elements. Again, arrays always start with an index of 0. To maintain the readability of our code, programmers will use meaningful variable names. They will also use a naming convention called lower camel case. The rules of this naming convention are as follows. The first letter of the first word in the name is lowercase. The first letter of every other word is uppercase. There are no spaces in the names. This can be seen in the example we have shown here. This brings us to the end of this lesson, but you can see more in software design and development on our YouTube channel, Greif Business and Computing Science. Don't forget to tell your friends, and please don't forget to subscribe.